This is a circuit that I wanted to try. Put it on Vero board, and the only modifications I made from the circuit that I had found, which I'll show you in a minute, is added three 3400 microfarad caps to store power. I guess I better start by just showing you the circuit. What it does is it exploits the fact that on a 120 line at 60 hertz, 120 times a second, it's crossing the zero voltage line, or the zero voltage point on the sine wave. And even though when it crosses that line, there's still an electromagnetic field in the components, in the transformers. So what this circuit does is it switches an NPN transistor on only when it crosses the zero crossing point. So when this is switching on, there's essentially 0 volts. It's at the 0 point in its cycle, on its positive or negative going cycle. Here's the basic circuit to do that, and what I was real surprised with, which I may be able to show you in a minute, is on the output of the full wave rectifier, after this transformer steps down, the primary is connected to my mains. I got an amp meter in series with that. Secondary is feeding the full wave rectifier. I'm getting 10 volt DC out on the rectifier, but after the 0 point switching, and this is with and without caps, I'm getting 32 volt DC. This particular transformer has 2 secondary windings, so just to see what the effect would be, I've got a blower, AC blower fan, that is it's not spinning to its full speed by any means, but it's continuously going. So that's running on one of the secondary windings, and the other secondary winding is powering the zero crossing circuit, zero crossing switching circuit, which in turn is keeping these 3 caps charged. I did pull the voltage down to 6.5 volt, but that's also driving a 7805 regulator and a 10 watt, well, no, this is a 1 watt LED. I had a Cree LED module right there, and it was lighting it up pretty blindingly. And I'm getting 0.3 microamps is being consumed by the transformer, which is just connected to my AC outlet. So 120, 60 hertz,